Okay, so today we're going to solve radical equations. A radical equation is an equation with radicals that have a variable in the equation. When solving a radical equation, remember, you need to identify any restrictions on the variable. So restrictions can include the denominators cannot be equal to 0, and the reason why is you can't divide by 0. And the radicands, that's the part that's inside the radical, must be positive if the index is an even number, meaning if it's a square root, a fourth root, a sixth root, it has to be positive inside, because otherwise you can't find two numbers that would multiply to get negative, right? And after you've done this, you need to identify whether any of the roots or the answers are extraneous, meaning you need to reject those solutions. And the reason, and the way you do that is you need to see if it satisfies your original equation. So the key here, just like all algebra, is to check your solutions, but this is especially important because you might be rejecting a solution. Okay, so let's start with example 1. So solve this equation, then verify the solution. Normally I wouldn't say verify the solution. It'll be up to you to do that. So identify any restrictions. So again, the inside of the radical has to be positive. So x minus 5 is greater than or equal to 0. So if I solve that by moving the 5 over, I would get that the restriction is x must be greater than or equal to 5. So if I get a solution that isn't in that realm, I would reject it based on that as well. Okay, so we need to isolate the variable to one side. So that means I need to get rid of the 3. So if I do that by adding 3, what's negative 1 plus 3? Well, that would be 2. Once we get the radical on one side by itself, we're going to square both sides. A square will undo a square root. So if I square both sides, I'm just going to write it and show my steps here. Whatever I do to one side, I do to the other. That's Algebra 101, right? So I'm squaring one side, squaring the other side to compensate. Again, a square undoes a square root, so I'm just left with x minus 5. And then on the other side, I get 4. You're supposed to combine any like terms if you need to. If there's still radicals that remain, you need to start all over again, get one of the radicals by itself, and of course, solve the solution. So if I add 5, I will get x equals 9. So let's verify that this works. So we're going to put in 9 minus 5 minus 3. So that is the square root of 4 minus 3, which is 2 minus 3, which equals negative 1. And that was what I was supposed to get on the other side. All right. Oh, I should mention on below this in yellow here, check your answers in the original equation. Also check your answers against the restrictions. So you need to check it both ways. So in this example, we got 9, which is definitely greater than 5, and then I checked my solution. Okay, so we're going to try example number 2. So again, the same thing happens. We need to isolate the radical. So I'm going to move the 6 over. So I get 2 root x plus 1 equals, if I subtract 6 to both sides, I get 6. Now, sometimes it's not possible to divide by 2, and you can keep the 2 there if you like, and then square it. But if you can actually get rid of that coefficient of the radical, I would. So I'm going to divide both sides by 2. So then I get x plus 1 equals 3. I'm going to square both sides. I get x plus 1 equals 9. So x equals 8. Now I forgot to do the restrictions at the very beginning. So I'll do the restriction right now. The restriction is x plus 1 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 1, which x equals 8 definitely is. Now I'm going to do my check. 2, 8 plus 1 plus 6. So that's 2 times the square root of 9 plus 6. So the square root of 9 is 3. 6 plus 6 is 12, and that's exactly what I got. Okay, next one. I'm going to start this time with solving my restriction. My restriction is 3y minus 1 has to be greater than or equal to 0. Move the 1 over. 3y is greater than or equal to 1. Divide by 3. Watch when you're dividing or multiplying both sides. By a negative number, you need to switch the inequality sign, but in this case it's positive, so I don't have to worry about that. So my restriction is it must be greater than or equal to 1/3. So I'll write out my question, but at the same time I'm going to move the 2 over to the other side. So if I move 2 over to the other side, I get 7. I square both sides. 3y minus 1 equals 49. Move the 1 over, I get 3y equals 50. So y equals 50 over 3. So 50 over 3 is definitely greater than 1 over 3. So that works. Now for our check, the square root of 50 over 3 times 3 minus 1 subtract 2. So the 3's cancel, and I'm left with 50 minus 1, which is 49, and the square root of 49 is 7, minus 2 is 5. So that checks. Okay, so then we get into equations that contain 2 radicals. So in this case, we have restrictions on both. So the thing is if you have a restriction on both, you have to figure out what the overriding restriction is, meaning one can't undefine the other. You have to have them defined for both. So for instance, on the left-hand side, x minus 8 has to be greater than or equal to 0. So that means x has to be greater than or equal to 8. On this side, 3x plus 1 has to be greater than or equal to 0. If I move the 1 over and divide by 3, I get x has to be greater than or equal to negative 1/3. So if we think about this on a number line, here is negative 1/3, and here is, say, 8. And this has to be greater, sorry, it's supposed to be filled in, and this has to be greater. So does everybody see, like, in between negative 1/3 and 8, there's an undefined region for the left side. So the overall restriction then, of course, would be it has to be greater than 8 for it to work. So, next one. Isolate a radical on one of the sides. So I'm not going to move the 2 over to isolate totally because I have 3 and then I get into fractions. I don't really want to have a fraction. It doesn't divide nicely. So I'm just going to keep the 2 by itself. But if there was a plus 1 or something else, you need to move that over. So you just have the radical by itself. The thing about having a coefficient of a radical, you just have to remember to square that. And it gets a little bit complicated when you have, now you're going to have a distributive property. So I'm going to show this step here. I'm going to square both sides. Oops. I'm going to square both sides there. Oops, what just happened? I'm going to square both sides. There we go. So when I square 2 root 8 x minus 8, it's 2 root x minus 8 times 2 root x minus 8. So that is 4 times x minus 8. Remember I told you to get in the habit is if you have an root of x minus 8 times root x minus 8 is just x minus 8, right? So, and then on this side you get 9. Again, it would be 3x plus 1. So here's where you have to be careful because you have now a distributive property. So I'm going to multiply these in. So I get 4x minus 32 equals 27x plus 9. So if I move I don't know, I think I'm going to move the, it doesn't really matter, I'm going to have negatives on either side. I think I'm going to move the 4x over to the other side, so then I get 23x. If I move the 9 over to the left side, I'm going to subtract 9, so I'll get negative 41. And then this doesn't, okay, so this doesn't divide very nicely, that's okay. So x is going to be negative 41 over 23. So my restriction is it has to be greater than 8. Ooh. So does that mean it works? No. That means there is no solution. Meaning there's no way I can actually get anything to solve this correctly. Okay, let's go on to the next one. So now we actually have like radicals. So if we actually tried to get the radicals to one side, we could actually combine it. So I'm going to subtract 4 and add 3 root 2x at the same time. Hopefully that doesn't confuse anybody. I'm just showing my steps here. So negative 5 root 2x plus 3 root 2x would be negative 2 root 2x. And 8 minus 4 is 4. Now on this, this time I could actually get rid of the coefficient of the radical because 4 does actually divide. So if I do that, I get root 2x equals negative 2 because I divided. Now I forgot to do the restrictions. Let's do the restrictions right now before I continue. Again, I can't stress how much the restrictions are important. So 2x has to be greater than or equal to 0, which means x has to be greater than or equal to 0 if I divide by 2. So anyways, now we're going to, there's something you should recognize. I'm going to go back to this in a second. But so if you go on your next step in your algorithm is to square both sides. You get 2x equals 4 and x equals 2. And you're thinking, oh, your restrictions, everything works out good. Now this is I put this example in here as proof of why you need to check your solutions. Okay, so I'm going to check my solutions. So here's my check. 4 minus 5 root 2 times 2 is 4 equals 8 minus 3, and 2 times 2 is 4. So then I get 4 minus, this gives you a 2, so minus 10. And this gives you 2 over here, so we get 8 minus 6. So we get minus 6 is equal to 2. Well, that's not right. Which means my solution is not correct, meaning I need to reject this solution. So here's the thing. At this step right here, we could have said there was no solution at that point. I'll abbreviate NS. And the reason why is I want you to think about this for a second. Can you have a radical equal to a negative number? Can you square root a number and get a negative number? Ever? No. So if you can recognize this, you can go directly to no solution. You don't have to solve the rest like I did. I just wanted to show you that if you don't catch that and you solve it, you actually get an answer, but then, and it actually fits your restrictions, but when you check it, it doesn't actually work. So you need to check your restrictions and you need to check your solutions. So both have to work for you to actually get the correct answer. Okay, let's go on to example 6. So this time I have a radical on both sides. So the step is to isolate one variable, one radical on one side. Now you can't combine these radicals, so it's not like the previous example. We're good to go. We're good to square. So now if I square both sides, do you see what happens? On the left side I get x plus 2. That's good. But on the right side, this is an actual FOIL. So what happens here is we're going to get a radical still. And so the common mistake is people just say the answer is 9 minus x plus 7. But that's not correct. The correct answer is a FOIL, which I'll show you. Remember, 3 minus root x plus 7, the whole thing squared, is 3 minus root x plus 7 times 3 minus x plus 7. So first you get 9. Outer you get minus 3 root x plus 7. Inner you get minus 3 root x plus 7. And last you get plus x plus 7. I'm going to put that in brackets just in case you ever get a number in front. So now we're going to combine like terms. So x plus 2 equals, well, this bracket really doesn't mean anything, so we're going to have a 9 and a 7, so it's going to be 16 plus x minus 6 root x plus 7. Everybody see what I did? Combine those, and I combine those. So I'm going to get the radical all by itself on one side, so I'm going to move the 16 over and the x over. So I move the 16 over, I get minus 14, and if I move the x over, they actually cancel. So I get minus 14 equals minus 6 root x plus 7. So I can switch both signs. So I'm not getting a radical equal to a negative number because I had a negative on both sides. I could divide both sides by 2. I don't think I want to divide by 6 because 6 doesn't go into 14. So I think I'm going to divide both sides by 2. So I get 7 equals 3 root x plus 7. So that's as isolated as I want for the radical. So now I'm going to square both sides. So I get 49 equals 9 times x plus 7. 49 equals 9x plus 63. And if I take 63 over to the other side, I'll do my quick subtraction. So that is 14 subtract 9 is, 13 subtract 9 is 4, and 6 subtract 5 is 14. So I'm going to get negative 14 equals 9x. So x equals negative 14 over 9. So now we need to find my restriction. So my restriction, which I forgot at the beginning, is x plus 2 has to be greater than or equal to 0, so x has to be greater than or equal to negative 2. The other one is x plus 7 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 7. So it looks like this is the overriding. It has to be greater than negative 2. So how many times does 9 go into 14? Once, right? So it is greater than, so it meets that restriction so far. This might be a little bit uglier to actually check, but you can still check. So we get negative 14 over 9 plus 2. So I need to, so this is my left side. So I need to get, first off, I need to make sure my radical is covering my 9. I need to get a common denominator. So that would be 9. So my 2 would be 18 over 9. Everybody agree? And then if I add that together, I get the square root of 4 over 9, which is 2/3. Okay. For my right-hand side, I get 3 subtract the square root of negative 14 over 9 plus 7. So 3 minus, well, what is 7 as a number over 14? Is 4 over 9. So that would be, well, 9 times 7. So that's 63 over 9. So what's 63 minus 14? That would be 49 over 9, which is 3 subtract 7 over 3. Oh, lots of fractions here. What's 3 as a fraction over 9? sorry, what's a 3 as a fraction over 3? Well, 3 times 3, so that would be 9 over 3. Subtract 7 over 3 gives you 2 over 3, which is exactly the same, so it checks. So this is my solution. Oh, we got another one here. So the problem here is we don't have the radical isolated by itself. So I'm going to move the 7 over and the radical over. So I'm going to get n plus 7 equals the square root of 5 minus n. Before I forget, I need to do my restriction. 5 minus n has to be greater than or equal to 0. I'm going to move the n over because I don't like dealing with negatives. So 5 is greater than or equal to n, which means n has to be less than or equal to 5 this time. So watch. It has to be less than. Okay, so now I'm going to square both sides. Again, you need to be careful. This is a FOIL on the left side. So I get n squared plus 14n plus 49 equals 5 minus n. Now I'm going to move everything over to one side in order to solve by factoring. So I get n squared plus 15n. And if I subtract 5, I get plus 44 equals 0. So I'm hoping that it's 4 times 11 because that makes nice answers here. So n plus 11, n plus 4. Looks like it adds up to 15n, so everything's good. So n equals negative 11 and negative 4. So looks like it fits my restrictions. We do need to check though. Okay, so left side, we got to check both solutions. So that means negative 11 minus 5 minus 11 is 5 plus 11. So this is negative 11 minus 4, which gives me negative 15. Oh, it doesn't look like it works. So I'm going to reject negative 11. Next one, negative 4. Again, this is the left side. Negative 4 minus the square root of 5 minus 4. So that's 5 plus 4. So this is negative 4 minus 3, and that gives me negative 7, which checks. So that means we only have negative 4 that actually works. Next one. Oh, well, let's try to get the 5 over to the other side so we get one radical isolated. I think the radical of 5x plus 4 is a lot bigger of a radical than the 3x, so it's probably easier to handle when I square both sides. So everybody see when I square both sides? Again, I don't get rid of the radical on the left side. I get 4 plus, if I FOIL this, I get 2 root 3x and another 2 root 3x, which gives me 4 root 3x. And then 3x, root 3x times root 3x is just 3x. And then on this side, it's just 5x plus 4. So once we do that, we do it all again. We try to get the radical by itself. So I'm going to move the 4 over. Actually, the 4's will cancel. That's kind of nice. So then I get 4 root 3x equals 2x when I move it, the 3x over. Now I could divide by 4, but I'm going to get a fraction. I don't want a fraction. So I'm going to leave it the way it is, and I'm going to square both sides. So then I get 16 times 3x equals, now what's 2x times 2x? 4x squared. So 16 times 3 is 48. So I'm going to get 48x equals 4x squared. Now don't think you can divide by an x because you don't know what x is. X could be a 0 for all you know. So we're going to move everything over and solve by factoring. So if I factor out a 4x, I'm left with x minus 12, which means x equals 0 and positive 12. Some people get confused that the 4x, if I set 4x equal to 0, do you see that my solution would be 0? Okay, so let's go back. My restrictions is supposed to be root 3x is greater than, sorry, 3x is supposed to be greater than 3x has to be greater than or equal to 0, which is x is greater than or equal to 0. And then the 5x plus 4 has to be greater than or equal to 0. Move the 4 over, I get 5x is greater than or equal to negative 4. So x has to be greater than or equal to negative 4 over 5. So it is actually the 0. Now it can equal 0, so 0 works and the 12 works, but we need to check our solutions. And I know people are like, I don't want to check my solutions, but seriously, you will reject one usually. So let's see. So 7, this is my left-hand side, and this is for x equals 0. 7 plus 3 times 0 is 0, so I get 7. My right-hand side, I get square root of 4 plus 5, which is 2 plus 5 is 7. So x equals 0 works. Let's do it for x equals 12. So the left side is 7 plus root of 36. So that's 7 plus 6, which gives you 13. My right-hand side is the square root of 12 times 5 is 64. So 64 plus 5, so that's 8 plus 5 is 13. So in this case, both of them worked.